We have two additional theorems in this section. Theorem number 2 says that if we have the function f less than the function g, then the limit of the function f will less than the limit of the function g when x approaches to a. And of course, both function f and g have to well defined at a. The Squid theorem, if we have the function f less than g and less than the function h, but the limit of the function f of x equal to the limit of the function h of x. When x approaches to a, then the limit of the function g will equal to L, which is the limit of the function f and the function h. So here is what's going on is the limit of the function f equal to L, the limit of the function h is also equal to L, g is in the middle, then the limit of the function g have to be equal to L. Here is the picture for this. So assume that we have the function h is the biggest, it is on the top, so h of x. And then we have the function g of x is in the middle, and we have the function f of x, which is the one below, is the lowest. The limit of the function h of x and f of x are both the same when x approaches to a. So let's assume this is a on the x-axis. Then the limit of the function g when x approaches to a in both sides, left hand side and the right hand side, have to be the same as the limit of the h and the function f of x. We will use the Squid theorem idea to apply. For example number 1, we want to show that the limit of x squared times sine of 1 over x when x approaches to 0 equal to 0. If we use the product rule in using the law before, in example number 4, section 2.2, is equal to the limit of x squared times the limit of sine of 1 over x when x approaches to 0. We cannot do this because the problem is that if x approaches to 0, 1 over x will be undefined. So we need to do some algebra to fix this. So the idea is we not directly calculate the limit of the function x squared times sine of 1 over x. Whenever you see the function sine trigonometry, we think about the domain of the function sine. So we know that the function sine of 1 over x for any angle, side of any angle, have to be between -1 and 1. So this idea is very, very important. This is the same thing as the cosine, okay? Sine and cosine between -1 and 1. Then in order to get x squared times sine of 1 over x, I will multiply x squared for this inequality. And the inequality does not change the sign because x squared is positive number for any value of x. Then I calculate the limit of negative x squared when x approaches to 0. You can calculate the left side and the right side and so on. However, we will get 0 for the answer. And also, we calculate the limit of x squared. We plug in the 0 and it's defined, so it's also 0. So think about this as the function h of x. This is f of x. The limit of f of x and the limit of h of x are the same. So the middle, g of x, which is the limit of x squared times sine of 1 over x, as x approaches to 0 must be 0 also.